Hi everyone, so today I will be going over with you the Math and Calculator worksheet. So this math worksheet will give you an overview of all the math skills that you will be using in chemistry this whole year. So let's see, so this is day one. I want you to read part one here. Read this paragraph first, okay? Once you read this paragraph, then do the try it section, so answer the question. So go ahead and pause the video and read the paragraph, answer the question, and then press play. All right, so for this first part, you need to know the difference between what is an exact number and a measured number. Okay, so a measured number is a number that you get from a measuring tool. So the measuring tools that we use in chemistry are things like beakers, graduated cylinders, rulers, thermometers, things like that. And an exact number is a number that you get from counting. An exact number could also be like a conversion factor. For example, 1 minute equals 60 seconds. So for this first question here, which of the following are measured numbers? So you have to go through each choice and figure out which one or which ones you get from using a measuring tool. So let's look at choice A. 1,000 mils equals 1 liter. So 1,000 mils equals 1 liter is like a conversion factor. So that is what we classify as an exact number. Okay, 14 beakers. 14 beakers is what we get from counting. So that is also an exact number. So it's put E for exact. And then we look at choice C, 2.7 meters. So we can get that number by using a meter stick, which is a measuring tool. So that's a measured number. And then choice D, 21.2 degrees Celsius, that is also a number that we can get from using a measuring tool, such as a thermometer. So the ones that are measured numbers are C and D. Now the reason why you need to know the difference between a measured number and an exact number, which will bring us to part two. Significant figures. So significant figures we abbreviate and we call that sig figs. So significant figures are basically the numbers in a lab when we're using various measuring tools. Those are the digits that are actually significant, okay? So we are only concerned with the measured numbers, not the exact numbers. All right, so what I'm actually going to do is I'm going to go to a new page and do my own examples and then go over all of the rules for counting significant figures or sig figs. So let's go ahead and go to a new page. Okay, so here we go. I'm going to write down my own examples. I'm going to write down a whole bunch of numbers. And let's do... Just making up these numbers here. Okay, so let's take a look at this number here. So in this particular number, we have these zeros in the front. When we have zeros in the front like that, we call those leading zeros. Okay, when the zeros are in the front, we call those leading zeros, and they are just placeholders. So the rule for leading zeros is leading zeros never count. Okay, so these zeros here don't count. Therefore, in this number, it contains two sig figs, just the 1 and the 4. All right, now let's take a look at this number, 207. You will notice that the 0 in this case is in the middle. When it looks like the 0 is in the middle like that and it's sandwiched in, we call that a captured 0. And the rule is captured zeros count. So then therefore that one has 3 sig figs. Now we look at this 190 number. That 0 is in the back. We call that a trailing 0. So the rule for trailing zeros only count if there is a decimal in the number. Okay, so you want to write that down. Trailing zeros only count if there is a decimal in the number. All right, so there's no decimal in that number. Therefore, this one only contains 2 sig figs. Then we take a look at this last number, 279.0. So once again, we see the trailing 0 in the back. So we remember our rule. Trailing zeros only count if there is a decimal in the number. And this one has a decimal in the number. So therefore, that last trailing 0 is significant. So we will count it. Therefore, that number has 4 sig figs. All right, let me write down another number for you with all kinds of, oh, that's a bad number. Hold on. All right. Okay, so in that number, see if you can count how many sig figs there are in that number. And if you get it right, there are, let's see, 1, 2, 3, 4, 5. There are 5 sig figs. So remember, these zeros in the front here are called leading zeros, so those don't count. Captured zero counts, and then that trailing zero counts because there's a decimal in the number. All right? Okay, so now let's turn back to the first page. Okay, so here we go. What I want you to take a look now, part 2. Okay, so part 2 here. Now I want you to do the whole entire try it section. Okay, so go through all of those and we will go over the answers in class. So make sure you do that tonight. All right, so let's go ahead and go to the next page. I'm just going to kind of do an example from each part and then you can finish the rest up for homework. All right. Okay, so here we are on part 3, rounding our numbers. So we're going to practice doing this, and I know many of you already know how to do it, but we're going to round it. So let's take a look at this first example here, and they want you to round that number to 3 sig figs. Okay, so if it wants you to round to 3 sig figs, you always look 1 digit past it. Okay, so look at 1 digit past the third number. If it is 5 or higher, you're going to round up. If it is under 5, then you're going to round down. Okay, so that's why if you were to round that number to 3 sig figs, it's just 75.3. Okay, so now what we're going to do is we're going to do part A together. They want you to round that number to 3 sig figs, and then they want you to round it to 2 sig figs. Okay, so if you round it to 3 sig figs, we're going to look 1 digit past it, and it's a 7. So that means we're going to round up. So it'll be 533, which will give us 3 sig figs, but we can't just leave the number as 533 because 533 is a much different number than like 530 something thousand. Okay, the magnitude of the number still needs to remain the same. So what we do is we just add the trailing zeros in the back, and then that will give us 3 sig figs because remember the rule for trailing zeros. Trailing zeros don't count unless there's a decimal in the number. Okay, now we want to round it to 2 sig figs. So if we want to round it to 2 sig figs, go back to the original number. Okay, you always look at the original number. So now we look at the third digit, okay, 1 digit past it, which is a 2, right? So that's less than 5. Therefore, we're going to round down and keep just the 3 in there like that. So that will give us the 2 sig figs, but once again, we have to keep the magnitude of the number the same. So now we'll just add the trailing zeros in the back. So you can see how that will give us 2 sig figs. Okay, so then go ahead and do the rest of those. And we will go over those answers in class, so make sure you do those for homework. All right, now on to this next part here, multiplication and division. So the rule for multiplying and dividing is that you're going to round your final answer to the one that has the least number of sig figs. So for example, we'll do part A together. Okay, go ahead and multiply that in your calculator and write down your answer. All right, and don't forget to include the units in your answer. So put that in your calculator, 4.5 times 0.28. Okay, so in your calculator, you should have gotten 1.26. Okay, now we have to round this answer to the proper number of sig figs. So we're going to look at both of those numbers that are in the calculation, and we're going to round our answer to the one that has the least number of sig figs. Okay, so how many sig figs are in 4.5? So that one has 2 sig figs, right? How many sig figs are in 0.28? 2 also. So this one's pretty easy because both of them are the same. So we're going to round this number to only 2 sig figs. Therefore, your answer should be 1.28. 0.3, and then don't forget your units. Inches times inches become inches squared. Okay, so go ahead and finish the rest of those for homework. All right, turn the page. Let's go to the next part. Okay, so now we are on addition and subtraction, and the rule is different. When you are adding or subtracting, you're going to round your answer to the one with the least number of decimal places. Okay, so least number of decimal places. So let's go ahead. Okay, so we're on addition and subtraction. Let's go ahead and do part A together. All right, so put that into your calculator. So 7.62 minus 0.875. Okay, so in my calculator, I got that to be 6.745. All right, so once again, we need to round this answer to the one with the least number of decimal places. So let's take a look at both of these numbers. How many decimal places are in 7.62? Okay, just 2 decimal places, right? 2 digits after the decimal. And then in the next one, 0.875, that has 3 decimal places. Therefore, we want to round our answer to have only 2 decimal places. Therefore, this answer will be 6.75. Okay, so I rounded up because you look 1 digit past it, which is a 5. Therefore, that 4 gets bumped up. Okay, because 5, if it's greater than 5, you round up. Don't forget your units. So this is kilograms. All right. Okay, so now what I want you to do is I want you to finish the rest of these here for homework, and we will go over those in class tomorrow. All right. Okay, so now I want to do an example with the scientific notation. So let's go ahead and turn to the next page. Okay, so here we are on scientific notation. For today, we're only going to do this top part here, and then we'll do all that next stuff, the second half of the worksheet, tomorrow. All right, so we're going to focus on this top half here. All right, so in this try it section here, they want you to write these numbers in scientific notation. So you can see that a lot of these numbers in this first part here, they're either really large numbers or they are extremely small numbers. So scientific notation is a great way to condense our number. Okay, they just condense our number because sometimes it's hard to count all those zeros in the front, like if it's 0.000051. It's hard to count all of those zeros. So if we just convert it to scientific notation, then it's a lot easier to read. And the same goes if it's a really large number, it's just easier to read if you condense it. And that's what scientific notation does. Okay? Now, also when you convert your numbers into scientific notation, they have to still maintain the same number of sig figs. So we're going to do part A together. Okay, so we have 6,650,000. Okay, so how many sig figs are in that number? So it has trailing zeros. So remember our rule for trailing zeros. Trailing zeros do not count unless they have a decimal, and there's no decimal here. So this one only has 3 sig figs. Just for the sake of this, there could be multiple answers to these depending where you place your decimal. I'm just going to ask you to place your decimal so you have 1 digit in front of the decimal. So we're going to place our decimal here. Okay, so we're going to convert this to 6.65. Okay, 6.65, and then I'm going to count how many times that I would have to move this decimal to get the same number. So 6.65 times 10 to something. So let's count how many times we're going to move it. 1, 2, 3, 4, 5, 6. Okay, so 6.65 times 10 to the 6th power. Okay, so don't forget that if you have a positive exponent, you're going to move your decimal that many places to the right. If you have a negative exponent, you're going to move your decimal that many places to the left. Okay, so this number here and the one that we converted over here, they are the exact same number. Okay, if you are ever worried that maybe you didn't do your scientific notation correctly, you can always check your answer by moving your decimal in the number here. So you put a positive 6, so you're going to move this decimal 6 places, okay, to the right, and it should look just like this number here, okay? The numbers are identical. Remember, the only difference is one is in the condensed form of scientific notation, and the other one is just in what we call the expanded form, all right? So that's what you're going to do for that part there. Now for this little section over here, they want you to turn it back to an ordinary number, okay? So you're taking it out of scientific notation. So once again, you still have to maintain the same number of sig figs, all right? So if it's a positive exponent, you move your decimal that many places to the right. If it's a negative exponent, you move it that many places to the left, okay? So let's just go ahead and then do part C. So it has a negative exponent to the -5, so move your decimal 3 places. So where I'm going to write this, I'll just write it down here. So 3.27, okay? And it's times 10 to the -5. So move your decimal 5 places to the left. 1, 2, 3, 4, 5. So these get filled in with zeros if I did that right. 1, 2, 3, 4, 5. Yep. Okay, so it would be 0.0000327. Just double checking. 1, 2, 3, 4, 5. Right. And so once again, you have to maintain the same number of sig figs. That has 3 sig figs there. That also has 3 sig figs, because remember, leading zeros here in the front do not count. Okay? All right, so that's day 1, part 1. I want you to make sure you finish this up for homework. We will work on this in class, and you can ask questions. All right? Good night.